So this next section, 2.5b, will be about solving radical equations and absolute value equations. But this video will be the part one. So part one and then part two. So we would take part one here, solving radical equations. Now, when solving radical equations, the first step is to isolate the radical. Isolate the radical. If you have more than one radical, then you're gonna try to make sure that one of them is isolated. Next step, eliminate the radical by choosing the appropriate exponent to raise both sides of the equation to. If you have the square root, the appropriate exponent will be 2. If you have a cube root, appropriate exponent will be 3. So you choose the right exponent to eliminate the radical that you isolated, at least one of them, or both of them, or all of them. Because what it says here, you have to make sure you repeat number 2 until there is no radical in your equation. And then you solve the equation for x, or for the variable of the equation. Step 4, must check for each solution, because there are some fixed solutions that you need to exclude from your solution set. Let's try the first example. The first example, we have 5 plus square root of 2x plus 5 equals x. Now, step 1, isolate the radical. We're going to move the 5 over. So let's subtract 5 to both sides of the equation. We got the square root of 2x plus 5 equals x minus 5. The appropriate exponent, step 2, to raise both sides will be 2, because it's a square root. Raise both sides to the power 2. The wrong thing to do would be thinking about distributing the power to get x squared minus 25. This is wrong, absolutely wrong. You can't do that. So what you're going to do here is you're going to write this into two expression that multiply itself. So it's the second side will be as x minus 5 times x, this is squared, times x minus 5, and then you FOIL it. So let's rewrite this as, this is x minus 5 times x minus 5, and then this side, the radical is canceled with the 2, then you are left with 2x plus 5. Now let's distribute this so we can get the expanded form of x minus 5 squared. When you finish this product, you would have 2x minus 5 equals x squared minus 10x plus 25. That's what, after you FOIL and simplify. Now we're going to move all the terms on one side to get the quadratic equation in standard form. We would subtract 2x on both sides. That would be negative 10x. And then we would add, oh, that's plus. This is plus. So we would subtract 5 on both sides. Subtract 5 on both sides. So the new equation in standard form will be x squared minus 12x plus 20 equals 0. 2 factors of 20 that add to negative 12 are negative 2 and negative 10. And then the factored form of the expression x squared minus 12x plus 20 equals, it would be x minus 2 times x minus 10 equals 0. Using the 0 product principle, we get x minus 2 equals 0, or x minus 10 equals 0. And then with that, we can add 2 on both sides and 10 on both sides of the second equation to get x equals 2 or x equals 10. Now the last thing you want to do is to think that these are your solutions until you check, before you check them. Let's check for x equals, let's check for x equals 2. So the original equation was 5 square root of 2x plus 5 equals x. 5 plus square root of 2 times the x value is 2. So 2 times 2 plus 5 equals value, the x value equals x. So the x value is 2. Now we're going to try to verify if this is right or wrong. So we get 5. This is 4. 4 plus 5 is 9 plus square root of 9. We want to verify whether this is right. So that's 5 plus 3, whether this is 2. This is 8, so that's not 2. So x equals 2 is an extraneous solution. Extraneous solution. So reject it. Now let's check for x equals, let's check for x equals 10. Squeeze this in. Check x equals 10. So we got 5 plus square root of 2 times 10 plus 5. Is it 2? We don't know yet. Now we're going to perform the part inside of the radical. That is 2 times 10, 20 plus 5, 25. So that's 5 plus square root of 25. Is it 10? Sorry, that's not 2. That's supposed to be 10 because x equals 10. So that's square root of 25 is 5. So 5 plus 5, 10. So 10 equals 10. This one checks. So the solution set will be just x equals 10. Because we had this solution, this one is checked. This one did not check. So that's why your solution is 10. Let's go to the next example here. To isolate the radical here, we would need to add 1. We get the square root of x plus 5 equals 1 minus x. And the appropriate value to exponent will be 2. We raise both sides to the power 2. X plus 5 equals 1 minus x times 1 minus x, and then FOIL. X plus 5 equals 1 minus 2x plus x squared. Move all the terms on one side. If you subtract x and then subtract 5, you would get the new equation, quadratic equation, that is x squared minus 3x minus 4 equals 0. We can break this constant c into 2 factors, -4, +1, and the factored form of the expression x squared minus 3x minus 4 is x minus 4 times x plus 1 equals 0. We solve this as x minus 4 equals 0 or x plus 1 equals 0. From this first equation, we get x equals 4, from the second one, x would be -1. Now we're gonna check for x equals 4. Plug in x equals 4 in this original equation. Square root of x plus 5 minus 1 equals -x. So that's the square root of 4 plus 5 minus 1. Is it -4? Let's see. That's 9. Square root of 9 minus 1. Is it -4? That is 3 minus 1. Is it -4? That's 2. That is clearly not -4. So this is rejected, right? Let's check now for x equals -1. Check. X equals -1. We're gonna have square root of -1 plus 5 minus 1. Is it negative? Negative for x, and then x equals -1, so -1. So that is the square root of 4 minus 1. Is it 1? Well, that's 2 minus 1. We want to check if it's 1. And yes, 1 is 1. So that is check. And then x equals -1 is the solution in this case. So your solution here is -1. Move to the next example here. In this example, we have more than one radical, so we're going to try to isolate one of them and then work with repeat step 2 until we get no radical in the equation. So let's start with adding the radical of x plus 2 on both sides of the equation. So that cancels this one on this side. We have radical of square root of 2x plus 3 equals 2 plus square root of x plus 2, right? Now the appropriate exponent that we want to use is 2, given that the index of the radicals are all square. So let me raise both sides to the power 2. So that is 2x plus 3 equals. Now remember, if you have a term plus another one raised to the second power, you're going to break it down as, let me break it down over here, borrow this room to this room here to break it down. So that's 2 plus square root of x plus 2 squared. We're going to multiply it twice. So 2 plus square root of x plus 2. Distribute this, that's 4 times 2 plus 2 times square root of x plus 2. This is 2 plus 2 square root of x plus 2 again. And then we get this times this. That's going to be square root of x plus 2 squared. That is just x plus 2. So plus x plus 2, right? And then when we combine like terms, we will have this one plus this one. That's 4 square root of x plus 2. And then 4 plus 2, that's plus 6, right? And then plus x. So that is going to be 4 square root of x plus 2 plus 6 plus x. Now let's move all these terms over so we can isolate this radical and repeat the process again. So we're going to subtract 6 and x on both sides, right? Cancel this and this. So we left with 4 we're left with 4 square root of x plus 2 here, right? And then that is just x minus 3 on this side. So let me move them closer. Thought I needed more room for that, but that's not. Okay, so now we're gonna raise both sides to the second power again. Since the index here is 2, we're going to raise both sides to the power 2. And then this one 2. So that's going to be x squared minus, we FOIL this one. We do not need that anymore, so I'm gonna clear this. X minus 3 squared is x minus 3 times x minus 3. So x squared, negative 3x, another negative 3x, that's negative 6x. And then negative 3 times negative 3 plus 9 equals 16 times x plus 2. That's 4 squared, and then this one squared is it's the x plus 2. Okay, so now we get that. We break it down. So let's distribute the 16 and then move all the terms of the equation on one side to solve the quadratic equation. So that is going to be, let's distribute this and then this. We get x squared minus 6x plus 9 equals 16x minus 30 plus 32, right? And then subtract 16x and then subtract 32 on both sides. So that's x squared minus 22x, and then that's minus that's minus 23 equals 0. That's minus 23 equals 0. So 23 can be written as negative 23 plus 1, negative 23 times 1, negative 23 times 1, and when we add, we get negative 22. So the factored form of the equation is x minus 23 times x plus 1 equals 0, x minus 23 equals 0, or x plus 1 equals 0. From the first equation, we get x equals 23. And from the second one, we get x equals negative 1. So we want to check both solutions. We want to check both solutions. Let me check the first one, 22. So 23. So that's square root of 2 times 23 plus 3 plus 3 minus square root of 23 plus 2. Is it 2? Right? I'm checking the first one here. So that is going to be 49, square root of 49 minus square root of 25. Is it 2? So that's 7 minus 5. Is it 2? 2 equals 2. Check. Now let me check. Let me check. X equals negative 1. So I'm gonna have square root of 2 times negative 1, 2 times negative 1 plus 3 minus square root of negative 1 plus 2. Is it 2? So that is going to be square root of 1 minus square root of 1. That is it 2. So that's 0. Clearly not 2. So this is not a solution. X equals -1 is not a solution. So the only solution of the equation is is x equals 23. So your solution is 23. And the last equation here is well, not that one, is this one, because it was a mistake here, right? So your equation is the square root of the cube root of, let me write it here, cube root of 2x minus 4 minus 2 equals 0. So we would add 2 on both sides, right? And then you would get cube root of 2x minus 4 equals 2. Now the appropriate exponent will be 3. Let's raise both sides to the third power, right? So that's going to be 2x, that cancels the radical, minus 4 equals 8. That's 2 times 2 times 2 times 2 to the second power. To the third power, that's 2 multiplies itself 3 times. That's 8. So with that, we can solve for x by adding 4 on both sides. 2x equals 12, divide by 2, x equals 6. Now this is the only solution we'll get. Let's check to see what it is. Let's check x equals 6 in the equation. So that's a cube root of 2 times 6 minus 4. Is it minus 2? Minus 2 on the outside. Is it 0? We're going to perform inside of the radical. That is square root of 12 minus 4 is 8. Minus 2, is it 0? We don't know yet. So that's cube root. That's cube root. So cube root of 8 is 2 minus 2. Is it 0? Yes, it is 0. So that checks. And your solution set for this equation is 6, the value we got for x. So this concludes solving radical equations. To solve radical equations, we need to remember, first we isolate the radical. If we have more, we isolate one. Second, we eliminate the radical by raising to the power appropriate. If you have radical index 2, raise to the power 2. If you have index 3, raise to the power 2, and so on. Third, first repeat the process in 2 until we don't have radicals in the equation anymore, and then solve for the variable. Then must check, because you may have a solution that you find from solving the equation, but when you verify it back in the equation, it didn't check it. And if it doesn't check it, this solution is called extraneous solution, or fixed solution, need to be rejected, will not be part of your solution set.